Hello 8th grade and happy Monday. Today we're going to try something new in math class and do a play pause it video. As you watch the video, make sure that you are making your paper look exactly like the screen on the video. Answer all of the questions to the best of your ability and make sure that you're completing the whole video. I know you're going to crush it. Let's get started. Let's look at your do now. Look at the first question. The letter D. Is that a translation, reflection, or rotation? That's a rotation. You can see that D made a quarter turn clockwise. It turned 90 degrees clockwise. Number 2. Is that a translation, reflection, or rotation? Well, if I drew a line straight down vertically between the E's, you can see that one is a mirror image of the other. That's a reflection. Number 3. Is that a transformation, a translation, reflection, or rotation? It's a translation. The F is pointing the same direction, it just moved to the right. Now let's think back to some of the work that we did with angles last Friday. Look at number 4. I can see that the measure of angle 2 is 45 degrees. Which angle do I immediately know is the same as angle 2? Angle 4 has to be equal to angle 2 because they are vertical angles. So I can fill in that angle 4 is 45 degrees. How could I solve for angle 1? I know that angle 1 and angle 4 are on a straight line. Angle 1 and angle 2 are also on a straight line. A straight line is 180 degrees. Angle 4 takes up 45 of those degrees. So, what's the measure of angle 1? The measure of angle 1 is 135 degrees. That means that the measure of angle 3 is also 135 degrees because the two are vertical angles. Now you try number 5. Angle 3 is 83 degrees. Solve for the other three angles. Angle 1 must be 83 degrees because it is vertical to angle 3. I can subtract 180 minus 83 to find that angle 2 and angle 4 are 97 degrees. Now you try number 6. If angle 1 is 157 degrees, what is the size of the other three angles? Angle 2 is 23 degrees. It's on a straight line with angle 1. They are supplementary. Angle 3 is 157 degrees. It is a vertical angle to angle 1. And angle 4 is 23 degrees. It is a vertical angle to angle 2. Now let's look at some transformations. Translate F 3 units left and 5 units up. When I do that, what's the new ordered pair for F prime? Go ahead and graph it on your paper, then enter the ordered pair into the boxes. When I translate 3 units left and 5 units up, the new ordered pair is 1, 2. Now let's make a reflection. Reflect F across the y-axis. If I'm reflecting across the y-axis, will F move up to quadrant 1 or over to quadrant 3? It will move over to quadrant 3. I'm reflecting across the y-axis. Go ahead and draw the reflection of F on your paper, then enter the new ordered pair into the boxes. F is 4 spaces away from the y-axis. So when I reflect it, it will be 4 spaces away from the y-axis again. The new ordered pair is -4, -3. Now let's rotate F 90 degrees counterclockwise. Remember, it's like I'm turning my whole grid 1/4 turn counterclockwise. Go ahead and rotate F on your paper, then enter the new ordered pair into the boxes. The new ordered pair this time is 3, 4. Now let's dive into today's lesson. Today we're going to talk about the effects of rigid transformations. On your notes, over the word transformations, let's make sure we're describing them as rigid. Remember, a rigid transformation keeps angles, side lengths, and parallel lines the same. So, for a shape to have been rotated, reflected, or translated, it has to have the same angles and the same side lengths. Let's look at the two examples. Is triangle DEF the result of a rigid transformation of triangle ABC? Yes, the side lengths are the same. The angles are the same. So, DEF is the result of a rigid transformation. Is EFGH the result of a rigid transformation of ABCD? No. Here, you can see that the two shapes are different sizes, which means that a rigid transformation could not change one into the other. Today we're going to practice identifying rigid transformations. So we want to see, was it a translation, was it a reflection, or was it a rotation? It might have also been a series of transformations. So a shape could have been translated and then reflected. Let's take a look at these two examples. In the first one, how did triangle XBG become X prime, B prime, G prime? This was a rotation of 180 degrees. I know it's not a translation because the shape is pointing in a different direction. Let's look at the next example. How did triangle FGY become F prime, G prime, Y prime? Here, the triangle was translated. It's facing the same direction. It was simply moved 4 units right and 1 unit down. Sometimes it's a little more complicated, and we have to look at a series of transformations to transform one shape into another. Let's look at triangle ABC and see how it could have transformed into triangle DEF. Here, one translation could not have made this change because DEF is pointed a different direction than ABC. So which two transformations could have been used to change ABC into DEF? Well, it could have been translated down first. After ABC was translated down, it could have been reflected over a vertical line. So the answer is that this shape was translated and then reflected. Let's look at another example. Which series of transformations could have changed A to B? Well, here again, A could have been translated down and then reflected over the y-axis. If I had reflected A over the x-axis, the triangle would have been pointed downwards. So that is incorrect. Let's look at the third example. In this problem, how can I get from A to B? Well, here, a translation and a reflection would have worked as well. If I move A over and up, I can then reflect it over the x-axis to make triangle B. Let's look at the fourth example. How can I change the top triangle into the bottom triangle? This is a rotation, and a rotation counterclockwise 90 degrees. Now you try a few. How could I get from shape n to shape n prime? Well, if I reflected n over the x-axis and then over the y-axis, I would get to shape n prime. You can see that a reflection over the x-axis would have taken me to quadrant 4, and then another reflection over the y-axis would have n facing the correct direction as n prime in quadrant 3. Look at the second example. What transformation takes triangle ABC to triangle A prime, B prime, C prime? Here, it is just a translation. It moved down and to the right. Now look at the example with pentagon JKLMN. How can I move from JKLMN to J prime, K prime, L prime, M prime, N prime? Here, if I started with a 90-degree rotation counterclockwise, I could then translate the shape up and to the right to create the new pentagon. So the answer is a rotation, then a translation. Now let's look at our last shape. How would you translate TUVW into T prime U prime V prime W prime? Pay special attention to where each point is. In the original shape, U is at the bottom left, and in the new shape, U prime is on the top left. Here, a reflection and then a translation would have worked. If I reflected U, TUVW across the x-axis, U would move to the top left-hand corner. Then I can just translate the shape over to the right. You've done a great job with this video. Now it's time to get on IXL for practice. To log into IXL, go to BelieveStudent.org. Then, choose skill P2. If you've finished P2, choose skill P3. If you need help logging in, raise your hand. Do a great job, get a SMART score above 90. Have a great afternoon, 8th grade.